All right, this is lab B24, diluting the problem. Now the problem that we have is, in the last lab, we created circuit boards. And to create a circuit board, we had to dip the circuit board into a solution called copper chloride, which is 100,000 parts per million, and it's very concentrated, meaning it's a strong solution. It's also very toxic and corrosive. So when we poured the copper chloride on the circuit board, it created the copper path, but it also took copper off of the plate and made the copper chloride into a waste. So once we took the circuit board out, it became used copper chloride, which has copper in it from the circuit board. So the problem that we're talking today is about how do we take the copper chloride solution and make it less concentrated so it becomes weaker and it's easier to dispose of in a more healthy way so it doesn't affect the environment and cause harm to the living organisms. Before we start, you need to know what concentration means. Concentration is the amount of one substance in another substance. So again, we're using copper chloride, which has 100,000 parts per million concentration. You also need to know parts per million is a way of expressing the concentration of a substance in 1 million parts of another substance, which means it's just a measurement that describes the amount or the concentration of one substance in a mixture. So all it means it's 100,000 over 1 million in fraction form. But instead of writing that large number every time, they abbreviate it with ppm, parts per million. So again, this is very concentrated copper chloride, and we need to try to dilute it to reduce the amount. The next word you need to know is dilute. When you dilute something, you have to add water to it. The more water you add to the solution, the weaker it gets. It does not mean that it's going to change the solution chemically, but it's going to decrease the concentration of waste per volume of water. So it's going to make it weaker and less harmful to the environment when you dispose of it. So we are going to try to dilute copper chloride and see if it's safe to dispose of. Our challenge today is how much copper is in the used copper chloride solution, okay? Today we're going to use a seep-up tray, all right, and we're going to see the copper chloride and we're going to dilute it in each cup and see in the end which cup has copper still left in it. You will be needing this data table in front of you to record all your observations. Okay. So the first step is I'm going to add 10 drops of copper chloride into cup 1, which again starts as 100,000 parts per million. Okay. So this is cup 1. In your data table, all right, I need you to record what color you see. Okay, so it's a green color. We're going to record that. Okay, we're going to add the ammonia later, and we'll talk about this column at the end of the lab. Now, when we move over to here, it's the concentration. So how many parts per million did we start with? Again, on the bottle it said 100,000 parts per million, so 100,000 ppm. Again, as a fraction, that means 100,000 over 1 million. Again, we got the 1 million because it's parts per million. To simplify the fraction, all you have to do is cross off the zeros, and you're left with 1/10. So again, the concentration is 1/10 of copper. Okay. Now, for cup 2, okay, we're going to take 1 drop of copper chloride, 100,000 parts per million, and add it to cup 2. Then we're going to put the leftovers here. Okay. Now, this is the first cup where we're going to start diluting. So we're going to add 9 drops of water to this 1 drop of copper chloride. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if you look at cup 2, you need to observe the color. Okay, it should be a milky green color, so we're gonna put, it's light green, so we're gonna record light green. Again, this is cup 2, light green, okay? Now, how many parts per million is this? Again, what we did is it was 100,000 parts per million. So we had 1 drop of 100,000 parts per million, but it was also 9 drops of water. So that means there's only 1/10 of copper chloride in here. So we're gonna take 100,000 and we're gonna divide by 10. So this becomes 10,000 parts per million. Okay. Again, when we write it as a fraction, it's 10,000 over 1 million. And then when we reduce the fraction, again, you're going to cross out the zeros, and it becomes 1/100th. Okay, so the concentration is 1/100th. Okay, now, again, we're going to take 1 drop now of cup 2 and put it in cup 3. I'm going to put back the waste. Okay, and now we're going to, again, add 9 drops of water to cup 3. Okay, okay, so let's look at the color. Okay, it looks like it's pretty colorless. Okay, it might have a tiny hint of green. Okay, all right, now, what's the concentration? Okay, now again, we took 1/100th concentration and put it in here. So again, it's 100th parts per million of copper chloride to 9 parts water. So again, you're taking 10,000, dividing it by 10, okay, which means there's 1,000 parts per million, okay? Again, that means it's 1,000 over 1 million, and then we're reducing it, so cross off the zeros, and you get 1/1000th. Okay. All right, now cup 4, again, we're taking 1 drop of cup 3, okay, and we're adding 9 drops of water. Okay, all right, if you notice the color, again, it's colorless. So in cup 4, all right, we're gonna write colorless, okay. All right, again, we're taking 1,000 parts per million, dividing it by 10, because it's 1/10 less concentrated now, and it becomes 100. All right, the fraction is again 100 parts per million, so 100 over 1 million. And we're gonna reduce that to a fraction, 1 over 10,000, okay? All right, again, cup 5, we're taking 1 drop of cup 4, okay? And then we're adding, again, 9 drops of water to cup 5. All right, so let's record the color. Again, it's colorless, okay? So again, we took 100 parts per million, and it's 1/10 less concentrated, so 100 divided by 10 is 1, okay? So that is 1 part per million, so 1 over 1 million. All right, and then the reduced fraction stays the same. It's still 1 over 1 million. Okay, and one more time, we're taking 1 drop of cup 5 and putting it in cup 6, okay? And adding, again, again, 9 drops of water. Okay, record the color. Again, I don't see any green left, so it's colorless. Okay. This is now 10,000. All right, this is 1/1,000,000th. 1/1,000,000th. All right, and this is, sorry, if you go back to cup 5, 100 divided by 10 is 10. Then it's 10 over 1,000,000, and when you reduce that, it is 1 over 100,000. That was my mistake. When you do the cup 6, it becomes 1 part per million, which is 1 over 1,000,000. And then when you reduce that fraction, it's still the same, 1 over 1,000,000. I was a step ahead of myself, so I do apologize. All right, let's look at cup 7 now. Cup 7 is going to be our control. So we are just going to use 10 drops of water for cup 7. Okay. All right. So as you can see here, we started with copper chloride, which is 100,000 parts per million, and we're adding water, more and more water, and you can see that the color is fading. Okay, so again, we're diluting the copper chloride and trying to get it less and less concentrated. All right, so again, the last cup of water is colorless. Okay, there's 0 of the copper chloride in it, 0 parts per million, so 0 and 0. Okay.